Hey, welcome to Dr. Pat TV. Today we're talking about the indefinite and integral, basically the anti-derivative or the antivirus for derivatives. Hey, if you're wondering what this dude's voice doesn't sound like him. I've been having a cold this week and my voice is gone. Oh, I'm cracking. I'm cracking. My voice is cracking like a teenage boy asking a girl out for the first time. So, yeah, that really happened to me too. Okay. All right. So now here's what we've got going. We've got what we call the indefinite integral. This is basically going backwards. We know the derivative, now we're going backwards. So instead of starting with the original function, we'll be starting with the derivative. All right, so before we begin this stuff, just going to have a little bit of fun. Got a cultural pop quiz for you. So if you know your movies, you should be able to figure this one out for you. So what do the following have in common? Jumping off the Brooklyn Bridge, sailing into a vortex storm, driving a DeLorean, calling on a telephone, or clicking your heels and saying there's no place like home. So, if you know your movies, basically all of those things will get you back home, get you back to where you need to go. So, those are all movies. So, a little side thing, try and figure out what all those movies are coming from. All right, so what we're talking about mathematically, we're talking inverses. That's what doing all those things, clicking your heels, get you back at home. That's what inverse is doing. Now, here's the technical jargon for inverses if you're a math person. Blah, 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 blah. Okay, what's that really telling us? Well, basically, what it's coming down to this inverses and formulae, okay? They basically undo each other, okay? They're going to bring us back, they undo each other. So, addition and subtraction, they undo each other. We've been using that for algebra for years. Multiplication and division, they're opposites, they're inverses. Exponential function and logarithms, inverses. They will cancel each other out when you do one after the other. Integration and derivative, that's our new relationship. So now we're basically playing with another idea for how do we get back where we started. Oh, yeah, mathematicians in a good time, aren't those inverses? Yeah. Be making popular with my math community, aren't I? All right, so let's get the idea across. It's lunchtime. I'm at work. It's lunchtime, and I want to go to Dick's get a hamburger. Hey, if you happen to be in the Northwest, you know exactly what I'm talking about when you're talking about Dick's Burgers. So come on up, visit it. Highly recommend it. All right, so I'm at school. I want to go to Dick's, pick up a burger for lunch. What do I got to do? Well, I got to go east on 200th, and then I go south on 99. And so then I can just basically get to, from school, get to Dick's. Now, inverses are about going backwards. How do I go if I'm now starting at Dick's and I finish my lunch? What's the directions to get me back to school, back to the office? All right, so I want to start at Dick's, want to end up at the community college. We've reversed. Our input output got switched around. The X and Y's get switched around. Okay, so now what happens here? Well, I have to go north on 99. If I'm at Dick's, I pull out. I'm gonna make a left, and I start going north on 99. And then when I get to 200th, I got to make another left, and I'm now going west on 200th, and I drive right back into the school. And so hopefully you'll notice that when we do the inverse, we are doing the opposite thing in the opposite order. Opposite action, opposite order. Instead of east on 200th, I'm doing west. Instead of south, I'm doing north. And then also notice you do the opposite order because it would not make sense for me to drive out of Dick's parking lot and go west on 200th. I just can't get there. So that's why the 99 and the 200th, they have to change order because that's the only way it would make sense. And so what we're looking at here is inverse functions, opposite action, opposite order. So now how does this make sense for us? Well, let's look at the steps for the power rule. So when we did the derivative, what do we know? Our two steps were multiply by the old power, subtract 1 from the old power. And so that's why you get this nice little nifty little math over here on the right side. You got n down in front because that's multiplying the old power. And then you got an n minus 1 up there because we're subtracting 1 from the power. Okay, if those are our two steps to do the derivative, what's the opposite thing to do? Well, the opposite thing to do would be add 1 to make a new power. So we're gonna what our second step in the original power rule was subtract one. So we're gonna move that to the first step, and instead of subtract, we're gonna do the opposite. We're gonna add. So we're doing the opposite thing, opposite order. And in this original, we multiplied. So in our new direction, we're gonna divide. Now here's the catch. We're not going to just divide any power. We're going to divide the new power. We multiplied by the old power when we took derivatives. Now we're going to divide by the new power. And so when we look at that, when we want to do the inverse of the power rule, go the opposite direction. Look what we've got. We've got an n plus 1 to the power. Basically, we're going to add 1 to the new power. And then look down here, we're dividing. So instead of multiplying on the derivative, we're dividing for the antiderivative. And we're dividing by that new power, the n plus 1. And so that's our steps for what we call integration. The antiderivative is basically opposite thing in the opposite order. Add 1 to the power, divide by the new power. It's a two-step process. And oh yeah, that little symbol here, this looks like a big, strong, tall S. Well, that's the integral sign. So called integration. All right, for exponentials, you may remember this one. When we had e to the bx, that would be like e to the 3x, e to the 12x, that kind of thing. What were the steps that we did? Well, when we did the derivative of exponential, we got itself, and then we multiplied by that b, that factor up there of the x, the coefficient of the x there. So those were the two steps we did for exponential when we took the derivative. Now, when we go the opposite way, we want to do the antiderivative. Well, what we're going to do is instead of multiply by b, we're going to divide by b. It's the opposite thing in the opposite order. And then get itself, well, the opposite of get itself is get itself. Kind of weird, I know. It's the exponential. It's so cool that it's got the base e for it, you know, kind of thing. Because in terms of the antiderivative and derivatives, E's for egotistical because it's all about itself. It's not about anybody else. Doesn't care about anybody else. It only cares about itself. So that's why I think that E there is so appropriate for the exponential. And so then basically here's what we're looking at for the antiderivative going the opposite way. You get the exponential back, but instead of multiplying, this time we divide. We're doing the opposite in the opposite order. Okay, so just remember that. So in the next part, we'll actually do some examples of doing the antiderivative of some expressions. Hey, I hope this helped, and I hope my voice wasn't too annoying today. Thanks, bye.